Go ahead and get started. Yeah, thanks everyone for joining. I'm Eric Korman, one of the co-founders of Striveworks. I lead machine learning here, and I'm going to be talking about evaluating LLMs and pipelines built off of LLMs such as RAG at scale. So, quick outline. I'm going to start off with some kind of generalities around, where MLOps is now, what the pieces of it are, how model evaluation in general fits into the MLOps kind of patterns, and then I'll get into some LLMOps specifics, and then I'll be talking about Valor, which is a recently released open source evaluation service, and I'll show a little bit about how it can be used for evaluating LLMs and RAG pipelines. Okay, so where are we as an industry in terms of MLOps? We've definitely come a long way over the last few years. As we've gone from kind of machine learning, and lots of the stuff I'll be talking about, and like this diagram is a little more specific to deep learning versus structured data. And there, as deep learning has gone from more science project phase to now in production, being very valuable to businesses across industries. We've kind of settled on, I think, some standard patterns and architecture for how you do model development at scale. It wasn't too long ago where I feel like standard practice was like sharing Jupyter notebooks on Google Drive and slacking each other serialized model weights. But that's not scalable, and that's no longer the case. And so here's kind of standard architectural pattern for how deep learning model development is done. Right, so you have some sort of data management service. This might be something like DBC, or just simply storing data sets in something like S3, some bucket blob storage, and then that feeds into some model training service, and so that's typically comprised of a bunch of different parts. So one, you have something that tracks your experiments for your training runs. So this is what stores and manages different hyperparameters, your train loss, different validation metrics. Typical examples here that are commonly used are ML flow, weights and biases, TensorBoard. Then another kind of key piece of model training is some orchestrator, something that provisions compute for training runs. With deep learning, you need GPUs typically to do model training, and we all know those are very expensive, and so you want to manage those resources very efficiently. And so there's tons of different tooling to do this now, stuff like Kubeflow or Ray or Prefect or Flight. And then kind of maybe the last big piece for model training is an artifact store. This is something that manages model checkpoints and weights, optimizer settings. So again, this could be just S3 or MLflow, or weights and biases also have some mechanisms for storing these types of artifacts. And then kind of, the last piece is model deployment, right? You have this trained model, you want to deploy it, and you want some service to manage that efficiently and at scale. And so, here typical things used are some of the offerings of Selden, Kserve, BentoML. And this whole kind of setup enables machine learning development to scale when you have multiple models, when you have big teams. This is kind of what it looks like. So how do we add model evaluation to this? And where does it actually fit? So I feel like this is kind of one of the last and final pieces of making model development very, very scalable and streamlined, is a process of how you do model evaluation. And I think we're starting to get to kind of some standard patterns around this, but it's definitely not quite as established as when you think about model training and deployment, for example, which makes sense because you need to have a model trained and deployed before you can even think about evaluating it, right? And I want to kind of call out, two flavors of model evaluation. So one, is something that you do while you're training. So in the process that is training your model, typically you have some cadence, every so many epochs or so many training steps. I'm going to take the model that I currently have and evaluate it on some validation data set. And then I'm going to post those metrics to that like experiment metric tracker service, my ML flow instance, weights and biases, that sort of thing. And that works very well. But then there's a second type of evaluation that doesn't quite fit in there. And so that's, if I have a model that's already developed, it's deployed, and now I have some new data set, it's not the validation data set that I used during model development. I have some new data set, and now I want to evaluate and know how well my model is performing on that data set. So, like experiment tracker services are not typically designed for this. So I'm going to kind of argue that we need a separate independent service to handle model evaluation for both of these use cases, but really, it's necessary for kind of the second use case, is having a central evaluation service that integrates with the other pieces of the MLOps pipeline. So, what do we really want from model evaluation? And so there's a lot of things I'll call out, just a couple. So one is, often, aggregate metrics are not enough, right? While like, papers on new techniques, will target, I just care about, accuracy on ImageNet, right? That's a very aggregate, single number to quantify model performance. But, obviously, in the real world and for business use cases, a single number is typically not enough, right? You want to be able to really prod your model and understand, how it's performing, for example, against different subsets of the data. Maybe you want to understand how your model is performing in certain geographic regions or based off of different demographics. You really just want to be able to stratify your evaluations across different slices of the data. And you also want to be able to easily understand, like, okay, my accuracy isn't great. What are the examples where the model is not giving the correct predictions? And a second thing is we want metrics to be centrally stored and queryable, right? Like, how things, and my team has definitely been guilty of this in the past, right? Like how's model evaluation sometimes done? Well, maybe you have all this nice infrastructure for streamlining training a model, but now when I want to evaluate on a new data set, I as a data scientist am pulling it in locally or working on some notebook. I'm using some evaluation library to evaluate it locally, and then I get some number, accuracy, mean average precision, what have you, and then what do I do with that? Well, maybe I copy and paste it into a spreadsheet that's shared with my colleagues, or like a Confluence or Wiki page, or I just Slack it to everyone. And that's not scalable. That's not auditable, right? It's hard to discover these things. If you come back to some Wikipedia page and it says, model X has accuracy 87, well, what exactly was the data set? When did that computation? Can I trust that? Right? It's just very error prone. So you really need a process where metrics can be centrally stored and queryable. And related to that is lineage, right? You want not just the metric, but exactly what went into that. What model, obviously, what data set, but then especially as we start talking about evaluating LLMs and things like RAG pipelines, the standard techniques to do that use another LLM, like a judge, right? Like you take a prediction from your RAG pipeline, and then you ask an LLM, ChatGPT or Mixtral, whatever, how good, rate this answer. And so evaluations in that case actually depend on another model. And so you really need to understand, you need to track what that model is, because if you ran that evaluation but switched your LLM, that's the judge, you're going to get a different number. And so, if you're trying to compare multiple models, that's not going to be a fair comparison. And then the last thing, or the fourth thing, which maybe is obvious, but I kind of want to stress this, is you want to be able to evaluate on your data. LLM leaderboards, like, the big LLM leaderboard that Hugging Face manages, that's great. That's a great starting point. But ultimately, you as a business user with some business use case, you don't care about how general some LLM is, how well it performs on HelloSwag. You care how it performs on your specific data. And so you want to be able to easily add the data you care about to an evaluation service and evaluate on that when you're doing model evaluation. And then the last important piece is, this needs to integrate with the other pieces of the MLOps pipeline, right? You want to seamlessly be able to have, your training process call out and use this evaluation service to do evaluation during training. You want your deployed models to be able to push their predictions to this evaluation service to get evaluated, right? This is definitely something that, doesn't stand alone and needs to integrate easily with the rest of your setup. So yeah, just to kind of summarize, big punchline, take anything away from this talk is, really think that you need a central standalone evaluation service that both computes and stores evaluation metrics, so that you can kind of achieve what was outlined as necessary on the previous slides. So what does this look like, adding such a service to MLOps? And so here's a high level diagram of kind of what we're proposing. So for each data set, you have a row or datum. So in the case of, say, an image data set, this is an image. In the case of a text data set, this might be a single question or a chunk of text. You want to post any annotations to that evaluation service for it to store. And so these are things like class labels, or if you're doing object detection, bounding boxes. You don't necessarily need to, for example, in the case of computer vision, you don't need to store the actual image for doing model evaluation, just the ground truth information. And then on the model side, whether you're model training, evaluating like a checkpoint, or your model deployment, evaluating a deployed model, you want to be able to post your predictions to this evaluation service. And then that's all the information that's needed to do model evaluation, right? Having, for each row in your data set, knowing what the ground truth is, knowing what the predictions are, then the service can compute requested metrics, evaluation metrics for you. And so, what the benefits of this are, again, you have the central service where metrics are queryable, they're discoverable. Another big thing, and this is going to be especially important when we talk about LLM evaluation, is you're posting predictions there. And so inferences are saved in the service. And so that means if you request a different sort of model evaluation, or you change some setting of your model evaluation, so, in object detection, this might be IOU thresholds. For LLM evaluation, this might be what model you use to judge to do the evaluation. If you change those settings, you don't need to rerun inference through the model you're evaluating, because those inferences have already been saved. And so obviously this is a big speed boost. It saves a lot of money, right? We know LLM inference is not cheap, whether you're, calling out to a third party like OpenAI, you're paying per inference, or if you're, using open source model or a model you develop, cloud GPU costs, buying a GPU, all that's expensive. You never want to have to rerun model inference when you don't have to. And then, the third big benefit we get from this is lineage, right? Because this service is both computing and storing metrics, we know exactly where a metric came from, what the ground truth information that went into computing that metric was, what the model predictions were, and any kind of evaluation settings that were used to carry out that evaluation. Okay, so Valor, so that's our fairly recently released open source evaluation service that realizes this kind of setup that we're proposing. And so has pretty simple architecture. So it's a backend service. It has a REST API. It uses a backing Postgres database to store all that ground truth information, metadata, predictions, evaluation results. And then users will typically interact with it via a client that kind of gives a high level wrapping around that REST API service. But you could also kind of interact, service to service with the Python client or directly with the REST API. And so again, kind of realizing that high level design before, this workflow involves posting ground truth data and annotations to the service, posting model predictions, and then requesting it to compute some certain evaluation metrics, which then get stored and are nicely queryable. And again, as per this kind of setup, I want to stress that this evaluation service shouldn't run inference itself, and it doesn't have to. And that makes it kind of completely agnostic of how you serve a model, what framework you use. You just need to write that little glue that converts, the output of your model into these Valor objects we have to encode predictions. And so it's kind of easily integratable with any sort of model serving framework. Okay. And then the other thing I want to highlight about Valor is it really has rich metadata support, where you can add basically arbitrary user-defined metadata to any objects in Valor: models, data sets, datums, predictions, ground truth. Because obviously, in the real world, the data we have a lot of interesting metadata, and we want to understand model performance against that metadata. So for example, if we have some big text data set, we might want to understand the data source of the individual text chunks in there, right? Did this come from Twitter? Was it New York Times? We want to track, when some piece of data was produced, right? Some timestamp attached to it. And we might want to understand how does model performance vary when I look at new data versus old data. And so we can use metadata filtering and evaluation to do that. Or similarly, geospatial is another big one we see, where attached to any data we might have location information, and we want to understand how our model performs in different geospatial regions. And so all that is enabled by metadata in Valor and its filtering. And so, some use cases of this. So, one is performance bias. Again, like, is my model biased against, certain locations or data sources, or maybe I have demographic metadata. And so I can use Valor to understand that sort of performance bias. And we have a blog post up on our website about how you can use Valor for that sort of thing. And then the other use case, which, I'll be talking about, is you can use metadata in Valor to track LLM pipeline settings. So, when we talk about RAG pipelines, there's so many pieces to an underlying RAG model. You have, LLM, you have an embedding model, you have all these hyperparameters into how you do chunking and, retrieval, and you want to track those because those definitely affect model performance. Okay, so now I want to start getting into kind of specifics for LLM. And so, what does LLMOps evaluation look like? And, a lot of what I'll say, could be, isn't RAG specific, but, that's a, very important, it seems to be like one of the most useful things that have emerged from LLMs. And so I'll kind of focus on this as an example, but, Valor and evaluation services, don't need to be kind of hyper tailored to RAG, but are flexible enough to kind of give you what you want for RAG evaluation. With LLMs and foundation models, that kind of slide I showed early on is kind of disrupted, right? Because now we're seeing that with things like GPT-4 and Mistral's models and Llama, I can often get away, and with the setup of RAG, I can often get away without training or fine tuning my model at all via how I was before, where I needed to do back propagation and actually training and adjusting model weights is typically no longer necessary. I mean, it's definitely true that a lot of people, and us included, are doing fine tuning, like parameter efficient fine tuning using LoRa, and that often gives better results. But definitely, you can get away without having to do any fine tuning. And so, what does this look like now? Well, this diagram has the basic pieces of a RAG setup. So, you have your kind of orchestration framework. Llama Index is probably the most popular one. There's also Haystack, Text AI, that interacts with a vector store that stores document embeddings or chunk of document embeddings. You have an embedding model that computes those embeddings, and then obviously some LLM that is used to take in the context and answer a user's question. And so, in this kind of prompt engineering, no fine tuning setup, training before is now kind of replaced by hyperparameter tuning. And so this is determining what LLM to use, what's your instruction or prompt templates, what embedding model do you use, what chunking strategy you use to divide up your documents and embed and store. And this is obviously just a couple of hyperparameters. There's tons more, like top K. What do I choose there in terms of how many retrieved documents I use as context? And so, I mean, basically, training is now replaced by validation on different hyperparameters. And so, what does RAG evaluation look like then? And how does a service like Valor really help? Well, again, like I just said, training is kind of replaced by evaluation. You have all these different settings, and you want to evaluate those in as streamlined a way as possible so that you can do comparison and determine, what's the best LLM, what's the best embedding model, and so forth on my particular data. And then, again, I'll stress, inferences are saved from the LLM, and so that's a big time and cost efficiency. And all these different pieces can be tracked as metadata in Valor. In particular, the LLM you're using as the judge of the evaluation needs to be tracked, and you can track that in Valor. And another big point I'll call out is every day it seems like a new LLM comes out, and you really want to make your operation, your product backed by LLM and LLM scale. Like, you want to be able to answer as quickly as possible and have a process for determining, what's the best model I can use on my data set, right? As once GPT-5 comes out, right, I want to determine, well, what's the improvement I get over what I'm doing now? And I want to determine that as quickly as possible. So now I just want to walk through some sample code of kind of what it looks like evaluating a RAG pipeline in Valor. Okay, so and I will stress, so Valor, which we kind of started around a year ago, started off more on the computer vision side. And so if you go to our repo, which I'll put a link in the chat at the end, you'll see a lot of stuff around computer vision, object detection, segmentation, that sort of thing. But we kind of quickly realized that the way we designed it, to the points that I've been trying to make, really fit very well into LLM and RAG evaluation. So over the past month or two, we've been working hard on adding all this support. And so that this stuff, like this code is not quite ready and not up on our repo yet, but this is something that we're working on now and should be released in the next month or two. But we know kind of the design and what it's going to look like. And so here just kind of quickly walk through these different chunks of code. So again, Valor is a backend service, right? Like the stuff that you're doing is not going to be like the evaluations are not going to be running locally. This Valor client is reaching out to this service that you can host yourself to do everything. And so Valor has this notion of a data set and a model. And a model, again, like Valor doesn't need any model weights or access to the model. This kind of model object is just used to track the predictions of the model. And so we go ahead, we create these data set model objects. Here's some sample data. Obviously, in a real use case, you're going to be grabbing this from some database or some data store or whatever. But here, just gave some sample data in terms of question and then category pairs. The reason I put a category here is just to show how Valor can use metadata. And so the use case here is something that we also want to kind of build internally, which is kind of a human resource, a company-specific human resource question answering service. And so here, this data is questions that are asking about company policies, and then I kind of categorize these in terms of like, is this about time off, benefits, so forth. And this setup, again, Valor is completely agnostic to what sort of RAG framework you use. Here, just for demonstration purposes, I'm showing what this would look like with Llama Index. So Llama Index has this kind of query engine notion, and that's what this object is. So I'm going to go loop through this data, and I'm going to get the response from the RAG pipeline. That's what this is. So this is Llama Index stuff. And now here, I'm going to create the corresponding information in Valor. So Valor has a notion of datum. Think of this as like a single instance data point row in your data set. Each one needs to have some UID. And then here, the data I'm passing to it is the question that's being asked. And then I'm storing the category of the question as metadata. We'll see later, I can then prod more fine-grained evaluation of, okay, well, I know how my model is doing overall, but how is it doing on questions that are just related to time off? How is it doing on just questions related to benefits? That sort of thing. So I add that datum to my data set, and then I add the prediction that came from the RAG pipeline to the Valor model. And so this links the datum that I had with the response. So in Llama Index, this response.response is the actual answer that the RAG pipeline gives. And then taking these source nodes from that response object, that gives me the context. So this is going to be what context did the RAG pipeline pull from my document store to pass to the LLM to answer this question. And so you want to, Valor allows you to add that context to a prediction because that's used for some evaluation metrics. There's metrics that quantify how much an answer in a RAG pipeline actually used the context. And then there's, to actually do an evaluation, there's this, simple call, evaluate LLM response. And then again, evaluation for LLMs, many techniques depend on another LLM to be the judge. And so here that's tracked and specified explicitly, hey, I want you to use, this API as the LLM to do the judging, to do the evaluation. And so what we're going to support is basically any LLM API that conforms to the OpenAI API. So obviously that's OpenAI itself, but then serving frameworks such as VLLM, and I may be Hugging Face now, you can use them to serve a model that conforms to this kind of standard API that OpenAI uses. So I specified my the endpoint I want to use for the judge LLM, and then I can make a different evaluation if I want to compare how does Llama 2 say my model's performing versus ChatGPT. I can do another evaluation with a different LLM, and then the nice thing is if I called this again, it wouldn't have to do any more computations. It wouldn't have to do any more API calls to the LLM that's doing the judging. All that stuff is cached. Those metrics have already been computed, so it'll just return those metrics immediately. And so if in another session or another user is doing the same thing, it's as efficient as it can be. And so you can also use the same call to actually query evaluations as you are for creating them. And then here's just a simple example of what I was talking about with using metadata in Valor to kind of stratify your evaluations or understand how your model performs on a subset of the data. So in this case, Valor supports this kind of binary expression setup, kind of similar to how many ORMs work, where if I just care about how the model is performing on data that are related to benefits category, I can form this binary expression looking at datum.metadata where the category field is equal to benefits. And so what this is going to do when you send this request is it's going to just filter the data to where this condition is true and evaluate there. So I can kind of see it as my model biased to different categories of the data. And then, in terms of discoverability, again, and kind of any session or user can, grab this data set, call get evaluations, see, what have I already evaluated this data set on? What have I evaluated this model on? And so this kind of gives you that discoverability, queryability. Okay. And that's it. Definitely open to questions. And let me paste these links into the chat. But yes, I'll say definitely don't hesitate to reach out. As I mentioned, we're very active development for this RAG and LM evaluation, and are definitely interested in end users, collaborators. So if you're interested in LM evaluation, don't hesitate to shoot me an email. All right, looks like no questions. All right, thanks everyone for coming on.